This is question 19 of the 2012 non-calculator paper. Bindi made 36 muffins. Some of the muffins were apple and some were pear. Both kinds of muffins looked the same. Tegan took a muffin. She had a 1 in 9 chance of taking a pear muffin. How many apple muffins did Bindi make? Pause the video and attempt the question. Now, if there is a 1 in 9 chance of taking a pear muffin, it means that, so a 1 chance in 9 means for every 9 muffins that one of them is a pear muffin. So for every 9 muffins, one of them is a pear. Now we know that there were 36 muffins, and we also know that 9 times 4 is 36. So the number of pear muffins, so the total number of muffins we know is 36, and we know again that 9 times 4 is 36. So therefore the number of pear muffins, because there's 1 out of every 9 muffins is pear, then the number of pear muffins is 1 times 4, which is 4. Now we need to see how many apple muffins are left. Because there were 36 pear muffins in total, the number of apple muffins will be 36. Take away these 4 pear muffins, which is 32. Another way of looking at this question is to say, well, if we've only got apple and pear muffins, and if there is a 1 in 9 chance of taking a pear muffin, then there is an 8 in 9 chance of taking an apple muffin. So the other way of doing this question would be then to say that there is an 8 in 9 chance of a apple muffin. So the number of apple muffins is 8 times 4, which is 32. So that is another way of doing this question. Okay. Question 20 of the 2012 non-calculator paper. Which one of these shapes has diagonals that cross at right angles? If you want, you can draw the diagonals in and attempt the question, or you might just know the answer. Pause the video. Okay, if you need to draw diagonals in, I mean, we can do that. So I'm just going to start putting some diagonals in. Let's just look at all of these shapes as well. This shape that I'm working on here is a trapezium. These diagonals do not look like they are crossing at right angles with that trapezium. These are definitely not right angles. A kite, let's look at a kite. If you actually know your properties of your quadrilaterals, you will know that the diagonals of a kite do cross at right angles. So the answer will be this kite here. Now, if you want to make sure, you can always put in the diagonals on the other diagrams. I'll just see, yep, these are fitting. So we've got the diagonals on there. And I've also put diagonals on this parallelogram here. So parallelogram diagonals do not cross at right angles for this one. The diagonals of a rectangle do not cross at right angles, because you can see you've got an acute angle there and you've got an obtuse angle there. Same here, acute angle, obtuse angle. Again here, acute angle, obtuse angle, and over here we've got all right angles where these diagonals meet. Now this is question 21 of the 2012 non-calculator paper, and the question is, how many edges does this prism have? Now when you might want to pause the video and attempt the question. Okay, now when you want to count the edges, you want to do them in some sort of order. So what we're going to do, we're going to count the number of edges at the top of the shape. So I'm going to start from this point here, and I'm going to go, right, I've got 1, 2, 3, 4, 5, 6, 7 shapes around the top. So I can just write that down. I've got 7 edges around the top. Now I'm going to look at the bottom of the shape. Now the bottom of this shape is identical to the top of the shape. So I should also have 7 edges around the bottom. Now because I've got 1, 2, 3, 4, 5, 6, 7 corners on the shape, see, on each corner of the shape I've got an edge going down. So I've got an edge going down here, 1, 2, 3, 4. There will be an edge down here, but you can't see it. That's 5. There'll be an edge here. That's 6. And there'll be edge going down here at the very top, which you can't see. That's 7 edges. So we've got 7 edges around the top, 7 edges at the bottom, and we've got 7 vertical edges. Okay, so that will be all the edges that we have. So 7 plus 7 plus 7 is 21 edges in total. Now for question 22 of the 2012 non-calculator paper. And the question says, this table shows the cost of planting a crop in paddocks of different areas. And we can see the area of the paddock up here and the cost of planting the crop down here, and we can see these values there. And the question is, complete the rule so that it agrees with the values in the table. Cost of planting crop equals something times area of paddock. Pause the video and attempt the question. Now, we need to see area of paddock. If we look here, something times the area of the paddock gives us the cost of planting the crop. So the area of the paddock times something will give me the cost of planting the crop. I mean, you can use these big numbers up here, but it's probably best to use these smaller numbers down here. So, sorry, I'll just fix that up. So what I'm trying to do, we're trying to say, well, 20 times what? 20 times what will give me 1600, okay? And so what I just set up there, 20 times something will give me 1600. Now I've written that down here. 20 times something is 1600. Now to work out what this something is, we can just do 1600 divided by 20 will give me that answer there. So 1600 divided by 20 will give me that answer there. Now to do 1600 divided by 20, look, we don't have a calculator, so we have to make this easier. We can take a 0 off the 1600, and we can take a 0 also off the 20. So instead of it being 1600 divided by 20, it's the same as doing 160 divided by 2. So half of 160 is 80. So the missing answer here, 20 times 80, will give me 1600. And I think I've just got that down there. So we know that therefore 20 times 80 is 1600. So our rule becomes this, that the cost of planting the crop is 80 times the area of the paddock. Question 23 of the 2012 non-calculator paper. A positive number n is multiplied by 4 and then 20 is added. Now if you multiply n by 4, that's n times 4, or 4 times n, which is 4n, and then we add 20. So that first sentence there is 4n plus 20. Okay, now it says, which of the following operations would give the same result? I want you to pause the video and answer the question. Now the first one says adding 20 to n and then multiplying by 4. Now if we do that, I can write that like this. We're adding 20 to the n. Whatever result I get, I need to put that in brackets because all of that whole result gets multiplied by 4. Then I can expand the bracket and I get 4 times n is 4n and 4 times 20 is 80. Now it's positive 4 times positive n, which is 4n, and 4 times plus 20, which is plus 80. Now if I look at the second one, now that obviously is not the same as 4n plus 20. If I look at the second one, adding 4 to n and then multiplying by 20. So I'll write that here. So we're doing n plus 4, which is adding 4 to n. Whatever result I get, I need to put that in brackets. So I put brackets around the n plus 4, and then I'll multiply it by 20 because the whole result of n plus 4 is multiplied by 20. So working that out and expanding, we get 20 times n is 20n and plus 20 times 4 is 80. So I end up with 20n plus 80. That's obviously not the same as 4n plus 20. Then we'll look at the third one. The third one says adding 4 to n. Now I've done that in the brackets. I've added 4 plus n, or n plus 4, putting brackets around that so that we get a total. and then multiplying all of that total by 5. So whatever answer I get there, I'm then timesing it by 5. So now I'll expand the brackets. 5 times n is 5n plus 5 times 4 is 20. And we get 5n plus 20. Now that's not the same as 4n plus 20. So we're hoping it's going to be the bottom one. So let's have a look at that. We've got adding 5 to n and then multiplying by 4. So we've got n plus 5, that's adding 5 to n. We put brackets around it so we get a total. And then we want to multiply by 4. So we've got 4 bracket n plus 5. Now expanding that, we get 4 times n is 4n plus 4 times 5 is 20. And that is the same as the answer up the top. So therefore that is the correct answer. So I've just circled that in there. Now for question 24 of the 2012 non-calculator paper. In a school library there are 1,000 books. 450 of the books are fiction and the rest are non-fiction. What is the ratio of fiction to non-fiction books in the library? Pause the video and attempt the question. Now we can see that there are 1,000 books and 450 of the books are fiction. So we can automatically work out the number of non-fiction books, and that would be 1,000 minus 450, which is 550. Now we need the ratio of fiction to non-fiction books. So we write fiction with the ratio symbol then to non-fiction. So fiction to non-fiction equals, now we've got 450 fiction is to 550 non-fiction. Now we need to simplify that ratio. And what we can do, we notice that we've got a 0 on the end of each of these, or you could actually divide both these numbers by 10. So 450 divided by 10 is 45. 550 divided by 10 is 55. Now we notice that both 45 and 55 can both be divided by 5. Sorry about that. And so 45 divided by 5 is 9, and 55 divided by 5 is 11. So therefore the ratio of fiction to non-fiction is 9 to 11. Okay, this is question 25 of the 2012 non-calculator paper. Dale is a beekeeper. The mass of 500 millilitres of Dale's honey is 700 grams. How many litres is 3.5 kilograms of Dale's honey? Pause the video and attempt the question. Now the first thing you'll notice in the question is that we've got different types of units, that we've got 700 grams here and 3.5 kilograms there. So what I'm going to do, I'm going to change this this 700 grams into kilograms. So 700 grams, to go from to kilograms, we're going from smaller to big units, and we need to divide by 1,000. So 700 grams is 700 divided by 1,000 kilograms, which is 0.7 kilograms. Now the way you can divide by 1,000, the decimal point on the 700 is at the end, and we jump back 1, 2, 3 spaces to put the point in front of the 7. So it's 0.7 kilograms. We also notice that for the answer, we need to give our answer in litres, and these units here are in millilitres. So I'm going to change those units, 500 mils, I'm going to change that into litres as well. So 500 mils, to change it to litres, we know that there's 1,000 metres in a litre. 1,000 millilitres in a litre. So we do 500 divided by 1,000 is 0.5 litres. Now if 500 millilitres has a mass of 700 grams, we can also just change the units and say, well, that's the same as saying that 0.5 litres has a mass of 0.7 kilograms. Now, the question is asking me how many litres do we have if the mass is 3.5 kilograms. So we can see here, we know that 0.5 litres has a mass of 0.7 kilograms. So we've got to work out how many litres has a mass of 3.5 kilograms. So to go from 0.7 to 3.5, we know that 7 times 5 is 35. So 0.7 times 5 is 3.5. And so 0.5 times 5 will be 2.5. So that I will just enter that in. So 2.5. So there you see 2.5 litres has a mass of 3.5 kilos, and I've just written the answer there as well.